Hi everybody, my name is Wils Dawson. I'm an engineer here at arcade.dev, and today I'm going to be walking through the new URL mode elicitation specification proposal that we have on the Model Context Protocol, or MCP. And to do that, I'm going to demo this TypeScript SDK. This is the official MCP TypeScript SDK that I've modified a little bit to fit with that proposal. And we're going to be getting into the code a little bit as we go, but I just want to orient us. I have the server here on the right side, and I have the client here on the left side. And just to orient us for what we're going to see once I start this up, I have the server running already. You can see it's running here, and then the client I will start in a second. And what we're going to see once I start this client is that both of these, the server and the client, are using OAuth to secure the connection between the client on the left and the server on the right. And that's a standard OAuth authorization or MCP authorization specification that is not changing as far as this proposal goes. I just wanted to show that this is compatible with the existing OAuth specification that MCP uses. So we're going to see a browser window pop up saying, hey, authorization successful, and that's the MCP client getting the OAuth token to be able to talk to the MCP endpoints on the MCP server. So nothing should be strange or abnormal there. The second thing we're going to see, though, is this new model of URL elicitation. So on connection, the server on the right is going to send the client an elicitation request. This is over server-side events, or SSE. And what's going to happen is the client is going to ask us if we want to consent to this URL being opened, and the server is going to be asking for an API key. And this URL mode elicitation that we're proposing is really useful for those secure or sensitive flows that regular form mode elicitation, or the elicitation that was released as part of the June 18th version of the specification, can't really do. The form mode can't really do secure. It should not be used for secure or sensitive data, because the client and the MCP client and the LLM have access to that data. The URL mode elicitation allows the server to interact directly with the user over a URL, over some web page, which provides a lot more flexibility as well as security. So we're going to see that in action here. I'm going to start the client, and again, we're going to see that OAuth flow come up, and we're going to see the URL mode elicitation prompt for, hey, give me an API key. Just for illustration purposes, I'm going to decline that request, just so you know. But here we go. So there's the authorization successful. That's the normal OAuth. And you can see back here on the client, we have this, hey, I've got this elicitation request. The server wants me to open this URL. It's asking to go to localhost API key form. I don't really trust localhost, like I said, right now. We'll click yes later. But for now, I'm going to say no, don't open it. And it says navigation declined. The server said, hey, I didn't get an API key, and I successfully sent that request, but I didn't get the API key at the end of it. Ordinarily, in a production case, this might be, hey, sorry, I'm going to terminate the connection. API key is required to connect to me and to use anything, so I'm going to terminate the connection. Again, in production, that might be fine, but for this demo, we'll continue here. So we can see back on the client, now I'm in control as the user. I can do several things, list the tools, do whatever I need to do. And you can see I can do the old form mode elicitation first. So I'll show you how that works. That can be useful to get contact information, preferences, feedback, things like that. So we can say that works over the server giving a set of JSON schema that the client can know about and validate. So we can say, hey, my full name is test, and my email is test@example.com, and my phone number is 555-5555, great phone number. And I can say, yes, that looks correct. I want to submit that. And cool, the server says, thank you for submitting that. Great, awesome. So that's form mode elicitation, but like I said, you wouldn't really want to use that for a secure, sensitive piece of information, for example, confirming a payment, because the client can programmatically confirm that payment, and you as the server developer or provider of that service don't really know that a human actually gave consent. So what we can do instead is leverage URL mode elicitation to do this. Now I'm going to call this payment confirm tool. And what's going to happen is it's going to return an error saying, hey, to use that tool, you need a elicitation is required, and here's the URL that you need to click. So we're going to see the same kind of flow that we saw at the very top where an elicitation is going to happen, but this is going to be because of an error in this tool call. So there we go. Tool call errored. We have this elicitation, same kind of thing. Hey, this is a security warning. Only go to this URL if you trust this. And this is again so that because there could be malicious servers that return weird URLs, the client is recommended to show some kind of security warning. This is an example. It doesn't need to be this flashy or scary, and it certainly doesn't need to be that if you control both the client and the server. But just for illustration purposes, some kind of warning if this is a public type of situation where MCP server and client don't necessarily have a strong trust relationship. But in this case, yeah, let's say I do want to confirm that payment. So I can say yes. And that opens my confirm payment URL. Thanks example.com. Really appreciate that. And we can close that window. And then back on the client here, we can see that, hey, we were unable to track the progress for that request. And I'm back here with my interactive prompt as well. And so if we go and explore a little bit about what's going on with that tool. So here's the code for that tool. We can see there's a lot of placeholder here, but all it does is take that cart ID parameter and do nothing with it. All it's going to do is throw this elicitation required error. And this lets a client say, hey, I can't continue with this tool call. I want to drop the request and send this error instead. Now it could be that instead of erroring, you can send a server-side event with a elicitation request as well and do something synchronously, keeping the tool call open. That's totally fine. In this case, wanted to illustrate that, yeah, you can error here. And also wanted to illustrate that you don't need to keep track of these elicitation errors or requests that you send necessarily. The reason to keep track of them on the server side is so that the client can then figure out what the progress of it is. And there are cases where the server won't know what the progress is. Potentially in this case, the confirmed payment is kicking it over to a payment provider like Stripe, where it's hard to know, is it done yet? I'm not going to really know until I get the funds maybe days later for real. I might have callbacks or webhooks along the way that give me an idea of maybe I think it's done, but there's going to be scenarios where you don't know. And so the progress tracking capability that we include in the proposal can be useful, and I have an example of that in a second that I'll show you. But I wanted to show people here that you don't need to track this stuff. And the client will, leveraging the progress utility in the MCP protocol already. So this is not a new capability necessarily, but the client leveraging that progress utility will gracefully handle, oh, I wasn't able to get the progress for this, no big deal. As we saw on the client, unable to track the progress, but no big deal. We could then call that payment confirm tool again once it's done, maybe with and then the server side the logic would know, oh yeah, I already have a user confirmation here that I recorded in some forum post. Cool, we're good. So the next use case that I want to demo is this third-party auth. So we talked about how, oh, there's my stream going around. So we talked about how at the very beginning, there's an OAuth connection and a secured OAuth connection here between the MCP client and the MCP server. That auth access token that was retrieved from the MCP server's authorization server. If you're following me with OAuth speak, there are times when the MCP server wants to expose a tool that uses OAuth for a different token, that it will need a different token potentially issued by a different authorization server, and the client should have no knowledge of that token at all. The MCP server is in fact acting and taking the role of an OAuth client to talk to that third-party API. So there's a lot of pieces going on here, but let's try to dive into the code for this third-party auth tool, and maybe that'll be a little bit clearer. Again, this is a sample code, demo code's not real. We're simulating a lot of things here, but here we are in the third-party auth tool. And we can see here that after getting the session and the elicitation here, we generate a tracked elicitation. And you can look at the code on GitHub for exactly what this does if you're curious, but basically we get an elicitation ID that is trackable for this server. And what we're going to do is simulate an OAuth flow. After 10 seconds, we're going to simulate that we got an OAuth callback from an authorization server. So this is simulating that after 10 seconds, the user authenticated to, for example, GitHub. And we're going to then, after 15 seconds after this tool was called, we're going to simulate that this server got those tokens from GitHub, for example. And now we have a GitHub token for this user that authenticated, and the server has the token. The client never saw it, never saw the user's password, never saw the token, never saw anything. The server can do this directly because of URL mode elicitation and that ability for the server to interact directly with the user. So we've seen this be useful across payment confirmation, API key, form-based gathering, which we haven't seen yet, but we will, and OAuth here, a third-party OAuth flow here. So let's actually see this in action. So let's call this third-party auth. And so we see the URL mode elicitation that we're used to by now. We can say yes, open that. Here it's again example.com. Let's pretend it's github.com, authorize endpoint, close this, come back. And we can see now that we're tracking progress. Oh, it just happened. So we were tracking that the third-party authentication was required, for example, to GitHub or example.com or whatever it might be. And then we can track, oh, we got the callback. Oh, we got the tokens. Now it's complete. And the client now got that, hey, that elicitation was complete. So now the client can correctly and programmatically and assuredly call this third-party auth tool again, knowing that the elicitation was complete and that error that it got before should not happen again. And those errors can contain multiple elicitations. If you need it to use multiple different services, for example, the client can do all of those things through one error response and then make sure they're all done, track that they're all complete, and then fire off the tool call again once that's all done. Now again, for this demo, if I call this again, it's just gonna do the same thing we just saw. We're not actually getting any tokens here for this demo, but you could imagine that might be the case. So progress tracking here, leveraging the progress utility that's already in MCP, allows the client to know predictably when that tool is safe to call again. All right, so let's try now showing that first thing that I skipped originally, that API key based elicitation at the beginning when we connect. So we're gonna, I spelled that wrong, terminate session. All right, so we close the session now, and actually I'll just start the client over here. So this is our normal OAuth. We now are saying, hey, I need your API key. And we can say, okay, hey, we're logged in as the demo user. This is a page that the server might host or another server on the same kind of infrastructure trust boundary. So it might use the same authorization server as OAuth. So we know in this case that the user is logged in, and we can actually see that there's a cookie. If I move my picture out of the way here, we should see that we have a demo session cookie. And this is encoded JSON that we can see, like demo user, a timestamp that it was created, the user ID, stuff like that. So we have a session cookie here that this page is reading from, which is pretty cool. So it knows, this page knows who the user is. We've authenticated. If the user wasn't logged in, you could imagine like a login flow before this page was viewed. We can enter our API key, 123. And we can see that we've been tracking that progress the whole time. The server got the API key 123 for our session. And again, we've been tracking that progress the whole time, waiting for you to submit your API key, waiting for you to submit your API key. The API key was received. So that's awesome. And we're now back in the control flow here. We can do whatever we want to do with the MCP client. You can imagine there might be other tools we could call that leverage that API key and things like that. That's the demo of URL elicitation, and hope you enjoyed, hope that was useful. Again, the code is all available on GitHub, and looking forward to your feedback. Thanks.